This is the first lesson on stoichiometry. Stoichiometry is the study of amounts, and it is based on the concept of a mole ratio. When you have a balanced reaction, the coefficients give numbers of compounds, not mass. So if you have a ratio, if you have a coefficient of 3 and a coefficient of 5, that means 3 molecules will react with 5 molecules, or 3 dozen will react with 5 dozen. But since we're talking big numbers, we usually talk about moles. So usually we're talking about moles when we talk about that. There are 4 steps to solving any stoichiometry problem. First thing you need to do is have a balanced equation. The second thing you need is to underline what is wanted, what is the unknown, what are you trying to find. Third thing down is write the given, write what you have, write what is known, including label and the chemical. Right now I'm talking about NaCl, H2O, C2H6, whatever you got. And the fourth one is to use dimensional analysis, which we talked about earlier in the year, to cancel units. In other words, you put in fraction bars. Depending upon what problem we're doing, will give you the number of fraction bars you want. For example, you have a given equation 2C2H6 plus 7O2 yields 4CO2 plus 6H2O. On quizzes and tests, I'll give you the balance equation. The question is, for the first example, how many moles of O2 are needed to react with 0.6 moles of C2H6. Okay, we're looking for how many moles of O2, so that's underlined in single line since we're going to be using this equation more than once. So step 1, balance equation. Step 2, underline what you're looking for. Step 3, write the given, which is over here, 0.6 mole of C2H6, and then use the number of fraction bars. If you're doing a mole-to-mole reaction, given moles, asking for moles, it will be a one-step problem, and you'll have 1 fraction bar. That one goes on top. Why you underline up here is because that looks like the top part of the fraction. Hey, here's the top half of a fraction. Put it in. So you got 7O2. On the bottom, we got to get rid of the C2H6 And what coefficient goes to that? The 2 does. What cancels is the compound on the mole-mole problems. So you multiply 0.6 times 7 and divide that by 2, and you get 2.1 moles of O2. So when you cancel, you're canceling and getting rid of the compound. That's how you do a one-step mole-mole problem. There's an additional type of problem where you have grams to grams, which is probably more widely used because we have scales. And when we weigh something in the lab, it's going to be in grams, not number of moles. So for the same equation up here, let's do this problem. How many grams of water are produced if 33 grams of carbon dioxide is also produced? In this case, since we're looking for water, I'm going to underline it twice so we don't get confused. We're looking for water, so it's 6H2O is going to go on top. Well, write down the same steps, go for it. Underline what's wanted, write the given label in the chemical. So we have 33 grams of CO2. The first thing we've got to do is get rid of the grams, so we've got to change to moles. So 1 mole over 44 grams, that comes from the periodic table, 12 plus 2 times 16. The grams cancel, and we're in moles of carbon dioxide. That's what we did here. We had moles. So now we do our fraction that involves the coefficients. So here's where we go with our 6H2O, and down here is 4CO2. Now the CO2's cancel, and we have moles of water. We don't want moles, they're asking for grams. So we got one more step. We gotta get rid of the moles, so 1 mole goes on the bottom. And up on top you have grams of water. And 1 mole is 18 grams. The great temptation is to multiply by 6. You're not doing that because we will have 1 mole, not 6 moles. The moles cancel, and our label is going to be left with grams of H2O. I'm going to give it a quick look here. That's 3/4, and things don't reduce down very well. So you multiply, you take 33 divided by 44, that's 1/4, times 6, or that's 3/4, times 6 divided by 4 times 18. I don't have a calculator handy, whatever it is goes here. If you have a gram to gram stoichiometry, you're going to have 3 fraction bars every time. You got your given. 1 mole is on the top, always. The middle comes from the coefficients of the equation, and 1 mole is on the bottom. So it's just a matter of plugging in what you are missing. This is the molar mass from the periodic table. Same thing there. This is coming from the equation. What is not required, but it is possible for extra credit, is if you're going from grams to moles or moles to grams, what you do is you just ignore one of the things. So these are a 2 fraction bar problems. if you have grams going to moles, over the given, and then the fraction bar, and then there we are here. So you just use the first two if it's grams to moles. If you start with moles, you don't need the first fraction bar. So doing this, you only use the last two, and your given will be there. That ends this lesson on stoichiometry.